Okay, we're officially started. We're back to Unix people. And hopefully that's what you're here for. Just a quick announcement. We don't have class next week. It's 4th of July. So you can do your barbecues and fireworks, and I don't know what else people are doing for 4th of July this year. But and do something 4th of July-ish. Celebrate your independence, but you're not, well, whatever. Americans will be celebrating their independence. Half of them don't know what 4th of July is all about anyway, so it doesn't really, I don't know what they're celebrating either. Okay, settle down. We're going to get started. Yoo-hoo. Okay, thank you. Alright, very good. We're done? We're ready? Okay, good. Let's officially start. Last time I was told we ended with 2A. We're going to skip 2B. To be or not to be is about using, it's about some basic Unix commands, which I've already covered. So lecture 2B is a repeat of, if you missed some of the earlier lectures, 2B is not bad. It goes over input, output, interacting with the system, working with files, and it just goes over basic Unix commands, and I'm going to skip that for the purposes of this particular class because it's too easy. And then 3B I'm also going to skip. 3B is about the VI editor. It's about 5 slides long. It goes into basic editor commands for VI, tells you about what VI is all about, and shows you how to run VI. If you're interested in VI, you don't have to use VI for this class, and I don't even recommend using VI, actually. But if you're interested and if you're curious about the VI editor, it's a text editor, you can go over 3B. That's going to tell you everything about that. What you should be doing right now, and because we're going to have a break next week and you're going to have 2 weeks without seeing me, because you're going to go through the entire week this week and then you'll see next week and we won't have class, I figured I should preview the first 3 assignments for you so that you have something to do so you're not bored while I'm gone. So assignment number 1 looks at, can we keep it down? It's I'm having a problem talking over some of you guys. I'll just be quiet to you guys. Are they? Thank you. Alright, there we go. Alright, and then as soon as I start talking, it starts back up again. So assignment number 1, Unix utilities. The first 3 assignments are all about Unix utilities, and I just want to run through a couple of guidelines for you in terms of what you need to do. Don't be afraid to have 1 or 2 word responses. It's a short question, so as an example, write a command to determine who is logged in on a specific terminal. Well, that might be, who am I? So, it's a 1-word response. You don't have to, some students go, it looks too easy. So, you can give me 1 through 10, or 11, and give me the response. Or you could take this, download it, and put, like, right here, who am I, or something, and, or you go answer, who am I, or something, or whatever happens to be your selected format. You can bold it, underline it, put it in red, or whatever. Anything you want to do to it, essentially. But what my concern was is that some people are wondering, what do I have to answer for this? What it asked for. And here's describe a situation where you'd want to use pine or write. What's the difference between pine and write? Don't write a novel. Give me like 1 or 2 paragraphs, or a paragraph, or just a simple couple of sentences. It's not quantity, it's quality. And another example, one of these is here, number 8, you use the man pages, the manual pages. That's what man stands for, to determine what grep command does for you. Report your results. Don't give me 100 pages. Just, maybe cut and paste the first paragraph. Looks like you ran man, so I can know, oh, here's the results. Here's what it does for me. Or you could simply don't cut and paste any of the reports on the results and just say, grep does this, and this is what I learned from the man pages. So you can take the output that you're getting and write me a description of the output in a simple, grep does this, blah, 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 and I'm not going to answer all these for you. Or you could cut and paste, but if you cut and paste, don't give me everything. Just give me 1 page or something. The date switches and stuff like that. All of this should work on a bootable Linux disk. It should work just fine on a Mac. All the commands are fairly generic. If you find one that doesn't work and there's a similar command, use the similar command, and in your response just say, hey, I'm on a BSD Linux system and this command didn't work, but this one did. And so you could substitute the commands, and if, let's say, something did change, if one of them asks you to use VI and you don't have VI, bring up Nano or bring up another text editor, and then tell me what happened with that. So depending upon the operating system that you're actually working with, your results might vary. So assignment number 2 is more of the same. However, it's a little bit on a different focus, and it's going to be more along the lines of what we're going to be looking at today, which is directories. So I'm going to go over 3B, I believe, and in there is going to be some information on CHMOD, change file types. So we'll talk about that. Also talk about directories and directory structures and trees, which is kind of the focus for today in terms of what we're trying to accomplish. So this particular assignment, the first one's on basic commands, the second one's on the directory structures, moving directories, and then what you're doing is you're going to fill in the commands that you used. So it's going to have you it's going to tell you to do a bunch of stuff. You don't have to keep the stuff, obviously. It doesn't have to be permanent changes. You're never going to use it again for another assignment. So you work through the instructions as an example. In your home directory, make 3 copies, one at a time, of your foods file, breakfast, lunch, and dinner. Well, okay, so the file inside of it has 3, well, the file is called foods. It could be a text file. So it could be a blank text file as an example. What your home directory is called, I don't care. You know, and so what you're going to do is give me the command that you used. And now you're going to do it three different commands. So, and these are the 3 different copies you're going to make. One's going to be called breakfast, one's going to be called lunch, one's going to be called dinner. So kind of simulate what it is I'm asking for, is what I'm saying. And, you know, it's going to be like, you know, mkdir space, you know. And then it's going to be 3 different directories that you're going to be making. So, you know, here make 3 subdirectories, one at a time, alpha, beta, gamma, you know. Move MV, dinner, into beta. So what I'm interested in is the command. Whether or not you do it or not, I'm not going to know. So don't take screenshots of your directory structure. I've had students do that, actually, which is why I'm saying that. Just give me the commands. It's on the honor system. I'm going to assume that you're doing it. If you do it, then, you know, in fact, this one here would be an interesting one to do. You know, remove the directory alpha. You know. Well, you could probably do a -R for recursive on some of it, you know. And you could use shortcuts if you want. You don't have to do things the long way. Use whatever tools and whatever stuff you can find. So. And then, lo and behold, assignment number 3 is probably something you can also do at this point. And this is going to be on another topic that we're going to talk about today, which is on the file access permissions. So this is going to give you an opportunity to use the CHMOD command and look at the essential file attributes for the 3 different parts. So file access permissions, so we're going to make a file named test in your home directory, and you're going to change the access permissions to look like this. And then we're going to do this, we're going to do that, we're going to try, and we're going to answer questions. So for example, number 1, make a file named test in your home directory. There's no answer to that question. You'll say, done. Okay, I'm not asking for anything. Or you could give me the command you used to make it. I don't care. It's unless it asks you for something, you don't have to answer it. Like number 2, change the access permissions so it looks like this. So change it, and then change it the permissions to this, and then try to edit the file. And what happens when you try to change it? So when you go through it, it's more of a learning process in terms of you know, filling out information that it's asking for, but leave it blank and don't worry about answering something that doesn't ask you for an answer. So I have some students that, you know, who do check marks. Done, 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 did it, did it, did it, did it. You could do that, or you could just leave it blank, is what I'm saying. Questions about assignments number 1, 2, or 3? And those are the ones you should be working on. Don't work on the projects yet. The first project's on Perl. We haven't covered it yet. So Perl and CGI, which is coming up next couple weeks. So. Alright, let's go into using in Linux lecture number 3A. Oops, if I can get it started correctly. The first part of this is really boring, so I'm going to kind of skip ahead. And if I cover this quick enough, we're going to hit the boot process. We're going to hit the boot sequence, and then that way we're ready to start in with CGI and some other Unix features and things next after we have our vacation. So basically the goal of this lecture is looking at it in terms of the operating system, the difference between the GUI, the command line. understanding some basic unit commands. What we're going to look at is the directories in the CHMOD, which is what you're going to need for those assignments I just showed you. We're not going to look at the operating system. We know about the command lines, right? We know about the GUI operating systems, right? We know what what an operating system does in general in terms of input, processing, output, right? The role of the operating system, which being the traffic cop, communication system, the toolbox. Yep. Okay, so that's how I can kind of skip through some of this stuff. We know about our command prompt, and we know that Unix is case sensitive, hopefully. That's good to note. So the commands are typed in lowercase. Interesting. Because I will have some of you who will use uppercase and say, CP doesn't work. CP works on almost every Unix system around if you use lowercase. So CP copy is not the same as C capital C, lowercase p, or capital C capital P. That's going to give you an error. Windows people usually have a difficult time trying to figure that out in the beginning, and then they go, oh, case sensitive, lowercase on everything. Because you're actually running a program called CP that's in the bin directory, and that's how you're doing the copy command. So these aren't like commands that are built in the operating system. These are actual files, and you're loading it by the file, and a capital C, lowercase p is a different file name than lowercase c, lowercase p. You will have to run all of these commands in a shell. We've seen shells so far. I don't care which shell you use, actually. All shells should support all of these different commands that you're running, because the commands that you're running are built in. The make directory, change directory, CP, rename, move, all those commands are already part of the system that will work in any shell. However, SH as a common cell, or CSH are probably your easiest methods if you're changing something. And in running all of these commands, you'll figure out how to use the switches, which is why I have you run so many commands. So in terms of the case sensitivity, you know about that. In terms of the general format, we have this thing called switches. Windows people aren't normally familiar with the concept of the switch. I'll have some examples coming up. The switches gives us extra features. So CP, a switch might be, minus R. Minus R says recursively copy, or a RM for remove, minus R for recursion. That's why what you do is you go up to the man pages. In fact, you should have man installed if you have a Linux distribution that you're booting from, or you can go to the internet actually. Type in MAN space CP. And what will end up happening is you'll get the man pages for CP, hopefully. Or if not, you'll get a link. You'll have to click on that to go to the man pages. And what you'll see are all of the command line arguments and all of the switches. Switches are different than arguments. An argument would be if I was using a CP command, the argument that it's expecting is, the destination and the origination. Well, usually the origination first. So copy this file, and then the second one is it's just like a regular DOS copy command. Copy from this file, this directory, to that file, that directory. Usually directory / file. So, and those would be considered the arguments. So some commands take more than one argument. Some of them take 2 arguments by average. I would say 2 is probably expected if you're doing a copy as an example. And the switches are going to be, well, copy, but how do you want me to copy it? Do you want me to do it, all of it? Do you want me to replace it when I copy it, overwrite it when I copy it? Do you want me to save it as another name when I copy it? All of the different arguments that might exist. So here's an example of the ls command. The ls command lists out the contents of a directory. So ls minus L is going to list it out in, I think it actually does it in 2 columns, and it gives you all of the information. And this is going to be star.html as the argument. So you can see the 3 components and how they're put together. So really the goal of that first exercise is to get you to write some commands. And it's not telling you what the commands are. You'll have to actually figure them out on your own. So not too bad. You can correct typographical errors real easily, because here's what ends up happening is when you start typing in commands, you start making error messages. You start making errors in your typing. A lot of people also like to use the up and down arrows to get to the history in terms of the shell that you're working in. So if you want, as a trick, if you want to run the same command again and you want to change it, you up arrow or you down arrow to go through the command list, and then you backspace to go over to change the particular command that you're interested in changing. Or you can use the delete key to remove characters to the left in some telnet clients. The backspace will also do that sometimes. Backspace, delete key. You can also use hotkeys like CW, CU to erase the entire line, to erase entire word. So you can go back word by word. Most people find something that works and they keep using it over and over again because it works. And it might be the long way of doing it. And I really like it when those people just like keep typing everything in from the beginning all the way over and over again, because I'm too lazy. I'll use the arrow keys and I'll find it. I did not use that command before. Here it is. Just change the directory name. There we go. Makes it easier. Makes it shorter. So let's talk about directories and directory structures, because you'll have to do some of this stuff on your assignments. So we have paths that begin with a /, and here's our /. It's kind of different because in Unix it's forward, and in Windows it's /, C:\\. Everything's a /. So it's the exact opposite. So same concept though. Similar concept though. Remember I talked about inodes and things and directory structures. But the symbol's different. Represents the root directory. So the /, we're at the top. It's not called anything. There's no drive letter. I will have some people go, well, what's the drive letter? C? Yeah, and they think when they're typing this in, they're going on their hard drive. Don't be concerned if you put a boot disk in there and you're up at a prompt in a terminal window. You're not your hard drive. You're not touching your hard drive at all. You're at a fake prompt. You're in a directory structure. In fact, you're not really touching the hard drive at all until you start doing something with it. Until you start making some changes. So typically only the system administrator might have privileges to the root. And what's going to end up happening is when you put your boot disk in, depending upon what you've installed or what boot disk you're actually loading up, or even if you're doing it on a Mac system, you're not going to have root unless you're the root, unless you're the master user of that system, which by default most people are. So you probably will have access to the root, long story short. But don't be concerned if you don't. You can do everything in the assignments. Even though it says go to the root, pretend it's at the root. So you may not necessarily have root access to. It should not prevent you from doing the assignments, essentially, is what I'm saying. So we have absolute path. So we have some concepts here. We've talked about some of the terms, but we haven't seen it in examples yet. But the absolute path begins at the root. So when we say something is absolute, it's from roots. And here's an example of a public HTML directory. The absolute path goes all the way back from home, be hecker, as an example, because we'd have a master home, and the home directory would have all of the users on the systems, all of their home directories would be in there. And then we would have, let's say, for example, public HTML. That would be part of home. So this would be referred to as the absolute, because what's going to end up happening in the assignments is going to say, give me the absolute path. Give me the relative path. You're like, what does it mean by that? You know, that's essentially how far back are you going to go? It absolutely goes absolutely back to the beginning. Relative is just, where am I now? So the relative path indicates the location relative to your present working directory. Where am I now? I'm in images. And we use the two dots, .. to say we have something back there, but we don't really care what. And we actually can type in .. images, and we can actually, from where we are now, change directories or do something in the images directory. We don't have to be changing directories. We could be accessing files, copying files, moving files, doing all sorts of different manipulations. So if we want to know where we are, we type in pwd, which will return the directory name where you currently are located. Because unlike the file manager, we don't have a graphical user interface where we can actually see all the folders and directories. And we don't have folders, actually. We have directories. And that here can't, it's actually a shortcut. It works, some of the notation does work in DOS, but for the most part, well, your backslashes are going to be wrong. Your // are going to be wrong. But you can use the .. actually in a DOS prompt. So it's kind of a universal kind of, I don't know, navigation, command line navigation. But for the most part, what I'm going to tell you applies only to Unix. So pwd is going to tell us where we are. So the directory that represents your personal section of the server is called your home directory. So then we have directory notation. This is kind of interesting because the / itself is representing the directory symbol. So when we use a /, we're saying that we are talking about a directory type file, not a regular file. Because everything in the system is actually referred to as a file until we preface that it's a directory file. The / and the dot here is the current directory. So we can say / dot and the name of a file. It says, well, in our current directory, run this, run that, or you know. And then we have the .. that represents the parent directory. We actually see this if we go dir in Windows. We see .. which is essentially mimicking the concept in terms of what dots are meaning. We have the parent, we have the current. But we don't use those. If we typed it, well, actually we could. We can type in the dots, actually, and use them in Windows. We don't have the tilde sign that represents the user's home directory. So you can say, you know, / tilde, meaning from my home directory / something, you know. I have another directory inside of my home directory. Why do we care about these notations? Well, it saves us typing. We don't have to type the relative or the actually, this is a relative notation. We don't have to type the absolutes. Go all the way back to root, because sometimes when we go all the way back to root, it's like 10 directories in the structure back. So when we create directories, we don't use spaces in the directory names. This is not like Windows, when we can say my space documents. That's long namespace. That's long style. That is that's a NTFS actually naming format. Not supported unless we add it on. Unless we add support onto the system and we extend the file system support. But the regular old standard, de facto standard Unix does not put does not put spaces in names or spaces in directories. It's just not allowed. Yeah, my documents does not exist. And we can use the underscore character or the camel casing to name directories, which is the underscore is referred to as a camel casing kind of technique, and I have an example of that coming up. And directory names are case sensitive, usually in lowercase with camel casing. So if we're going to put a space in, we can go my underscore documents. And if we capitalize the M in my every time we call that directory, or capitalize the D in documents, we have to actually capitalize it. It is case sensitive. I believe you can get away with that. I believe you can get away with that in Windows. It's not case sensitive, but don't quote me on that. So how do we make a directory? So you have to do, this is your second assignment actually, I believe, or your first one I think, as you use these commands. So what I'm going to do is go through all the commands for the directory structures. So mkdir, so that sounds pretty familiar, make directory. And then here's the directory name. If we don't specify it, it's at the relative. If we make a directory right here, it's going to put camping images in our current directory. So, which is perfectly legal. We don't have to specify the path in terms of where it's going. The file and directory permissions. If we go ls-l command, we're going to show the full details in terms of the list, including the file names, the owners, the names, the modified date, the size, and the permission sequence. And here are the sequences. So believe it or not, what I'm giving you is kind of an overview, and I'm not going to cover everything, but we're going to put permissions in here too, and leave the assignment to you to explore all of the different commands. If you have the book for the course, it's too easy that all the commands are in the book. Otherwise, I go on the internet and say, Unix, what's the command to make a directory? And it'll tell you. So, it's too easy actually to just give you all the commands, because then I'm doing the assignment for you. So. Alright, but let's take a look at the permissions for a second, because what I showed you before may have been numbers. Now I'm showing you the read, write, and the execute. So permission sequences found at the beginning of the directory listing. So when we actually do the ls-l, we see the particular first 10 characters as the directory permissions. So what we have is an indication of whether or not the file, as I mentioned before, this is kind of the interesting component. You start seeing how everything is a file when you start listing out. When you list out files. So some files are directories and some aren't. So sometimes you see a D, that means, oh, that file is a directory. Or you see a slash. If you see a slash or underscore space, that means it's not a directory. So here's a slash here. Point is, it's either set or it's not set. And then we have owners, groups, and world permissions. Some people call world public or other. The owner is the person who created the file. The group is in terms of the profile that's being set by the administrator. We have groups. We can put people into groups and then apply privileges to groups. And we say, well, everybody who's in the accounting group has access to the accounting directory, the shared folder or something. And these are read, write, and execute. Why they didn't use an E for execute, I don't know. It's an X. But read, write, execute. So if This particular case, we have read, write, and execute all three. Here we only have read and execute. We don't have write privileges. And here, same thing. We don't have write privileges. It's very uncommon to see write on group or on public or world preferences because, usually it's just the person who's created the file that should have a right to write to it. So the first character represents whether or not the listing is a directory. So if it's a directory, you see the D that will appear. Otherwise, you're going to see the space, or the dash that's going to show up, essentially. The remaining 9 characters are divided into the 3 triplets here. First one represents the owner, second one is the group, next one is the world. So read permissions. Let's look at in terms of what's going on in terms of these particular properties. So grants permission to view the contents of the file or the directory. So, which is the value R, or the value, which is going to be a slash to say no R. So, write essentially is the W, stands for granting privileges to modify the contents of the directory. You can have read without write, as we've seen in the example. You can have write. Well, you'd have to read the file in order to write to it, though. So if you can't read the file, you can't write to it, logically. Actually, if you can't read the directory, you can't write to anything inside of the directory. Because you can't get to the directory. So a lot of the commands actually kind of are interesting because the permissions that you set on the directory are going to affect what happens inside the directory and what you can actually get to. If you can't write to the directory, then you can't write to any of the files inside of the directory. But maybe you can read it. If you can't read it, you can't get anything anyway. So, the X stands for execute, grants permission to run the application or open a directory. So if you have a directory that you can't execute, it means you can't open it. But you can read and write to it. You just can't go into it, which is weird. So in changing permissions, you must first decide what number will represent the permission. So you can do this by determining whether or not the permission is turned on or off. And so we have zeros and ones that represent this. Because sometimes you see it, CHMOD 777. Or, because you never see this. This is what you see when you do the directory listing. When you do ls-l, you're going to see D's and R's and W's and X's. When you use the CHMOD command, you can actually use the D's, the R's, and the X's and everything. And we've also put numbers in. So people like the numbers because it makes more sense logically to remember. 755, 777. 777 is everything. 755, 750 is pretty common for public directories, HTML. Because it allows you to read it, but doesn't allow you to write it. So it gives you access to it. So to turn on the permission, it gets a value of 1. To turn it off, you have a value of 0. So after deciding whether the 3 permissions in the tuple are going to be on or off, you have a binary number that comes out of that. So you can convert the binary number to its octal equivalent, and then that's where you get those numbers that come into play. Octals being 0, 1, 2, 3, and the binaries being 0, 0, 0, 0, 0, 0, 1, 0, 1, 0. So you can kind of get the equivalent in terms of the number notation. So what you see a lot of on the internet are the equivalences. Say, well, what is this? That's 0. CHMOD 0. You've taken everything off, essentially. And then you have the 1, 2, 3, so it's 0, 0, 0. Which is how you come up with a 777, which is everything. If you gave it everything, you'd end up with a 7. So for 1, 2, 3 of the sets of permissions, it would be 777. Or 0, 0, 0, 0, 1, 1, 7, 5, 0, 7, 1, 0. Any combination essentially would work. Here up to 7. See, 7 here's got everything. 1 for everything. Which is why people go 777. Because well, why give write privileges, though? So you'd go 7, take off the 5, put a 5 down here. So 7, 5, 7. I'd go 750. Why do you want to execute it if it's on the HTML page? If you're going into public files for HTML, they don't need to execute it. So the browser just pulls the page. So you can go 750 or something. 755, 75, whatever. So hopefully you get the point. And this is the CHMOD I keep talking about. So you've established the octal number representing the permission for it. We've come up with 777 as an example because we want to give everybody permission for everything. We type in the word CHMOD and it gives us a directory or file for proper permissions. And here is a syntax for it. So we have, as an example, CHMOD 755 to the public _ HTML directory. It can be a directory name. It can be a file name. It can be an entire path. It can be, CHMOD 777 root. I'm going to put in the root directory or something, which may not necessarily be good. Because what you're doing is essentially allowing people to come in who own it, who don't own it, and who are the public, and change stuff in it, read stuff, write stuff, which is part of the security system, which is kind of interesting. In Windows, I believe if you make a file and you save it on the hard drive, everyone has access to the file. Am I wrong? I don't know. Unless you set up user accounts, I guess. User accounts, and then does it eliminate the abstraction of other people's files? It tried to do that actually, because you go into desktop and you go into user or something, and Windows 7, I believe, separated it out. I think Vista. Did it start with Vista? I'm not a Windows expert. And yeah, I remember something about the profiles or something, or the users or something, user level. And then it went down into, because Mac did the same thing actually, and then it went down into different subsets of that. Desktop was all different, the start menu was all different for each one of the users. But the files are still on the hard drive. So you could essentially go through and reformat the hard drive and ruin it for everybody. Huh? You'd have to have the admin permissions to reformat the hard drive. Oh, that would be good. Well, the same thing true for Linux and Unix. You'd have to have admin permissions probably to reformat the hard drive, but you'd also be able to mask out different sections of the disk so you couldn't attach it. I mean, you couldn't change to those directories or do something to affect other users on the system. So it's part of the security system essentially, is to do this. But it's also part of the file types. So as an example, our directories have a mask that say they're directories instead of just files, which is where that first D comes from. And also on executable files, if we have a file that is executable with that X at the end, and it's executable by everybody, or by whoever owns it or whatever, when you type the name of the file system recognizes it as being an executable. So it would be the same. You can have a text file that runs a script that would run in the same fashion as an exe file in a Windows system. And if it wasn't executable, you could still run it if it was a script, but it wouldn't go by its file name. So you can actually kind of change the mode in which the file is being treated as an executable file and let it be executable. So if you take an executable file like a script and make it non-executable, then you would prevent it from being run, essentially, unless you were in a scripting environment in which you were bringing up the script manually and running it instead of just running the file. So typically directories and executable files are given 755 permissions, while other files are given 644 permissions, root access, or something. Owner positions. So let's talk about navigating the Unix file system. So we move from directory to directory. We use the cd command, cd space /. So we say cd space and the path. In terms of what it is, we're looking at the path with a // or / separated out. So we can move from child to parent. We go cd space .. Remember before we had the relative, when I was showing you the relative path, the .. brings us back up to parent from child. So we can go back and back and back, forward by traversing with the dots if we want to. Here's an interesting one. We can move from the grandchild to the parent directory by going cd space .. So we skipped a level and back up from child up to parents. And this is going to come in handy when you look at that assignment because the assignments are going to have to use the dots. Here's to move from one child to a sibling directory. So you're in a directory // or this is a Windows thing, bhacker, and in there I have two directories, disk 1 and disk 2. I'm trying to copy some stuff over, and I'm in disk 1. I can use this command to go cd space .. disk 2, and I can go from one directory at the same level into another directory that's the same level in terms of the parent child. So go into the different child. And so the ls command shows you the contents of the particular directory, and you can add switches to the ls command to modify the command to to one switch to concatenate them, or to add switches to the list, to modify what the command can do. So to use more than one switch, you can concatenate them together. So here we have ls minus L. You can go T. Actually, you can run ls minus T, ls minus L. See, what you do is, when in terms of concatenation, you're just adding them to a list. So your switches become a parameter list. You think of it that way, which we haven't seen so far. So we can go minus LACT or something. And then when people look at that and go, what is that? Oh, that switch, but it's just one switch after another. So you don't put spaces in there. If you put spaces in there, it's going to think you're running a parameter or an argument instead of a switch. Because the format goes command, switch, argument, argument, argument. Everything in past the switch is an argument. So that's going to cause you problems. For some people who don't like to concatenate things together, who like to have spaces in between their switches, it doesn't work. So ls minus L shows you the long. L stands for long formats. A for hidden files. Now, I think that would be H, actually. Some of it's kind of logical, some of it isn't. So, long. Well, long, I like to think of details. I would have changed that to D, maybe. The detailed view, because that's what you're looking at in Windows. H for hidden, but it's not. It's A. C for listing of column formats. T for the sorted listing by the last modified date, or T for time. I think of it that way. LSA with the wildcard, with the asterisk at the end. All files starting with A, which is kind of like the Windows, star dot something or other for all files with an extension of this. Interesting thing is we're not required to have file extensions. You noticed in most of the examples, does ls have an extension? It's not ls.exe. If anything, it would be ls.o, but we're not going to call it that. So we don't play with the same file extensions, and I explained that a couple weeks back when I talked about the differences in the file systems structures between Windows and Unix, and that's because we've got those inodes and we've got the whole kind of different way of viewing it and resolving in terms of the runtime support. ls asterisk A asterisk file names that with A in them, before or after or inside of it somehow, or A asterisk asterisk A asterisk HTML with file names with an A in them ending in HTML. And then we have our 1, 2, 3, 4, 5, all 5 character file names. That you can't do in DOS. So with the question marks. Give me characters, of all. If you had a big old list of backup files, you can say, give me, the ones that have 5 characters, which means it's probably from a particular month or something. A month with 5 names, 5 characters in the name or something. And lists, and then here's an interesting thing. We've got the brackets ABC with an asterisk, all files starting with A, B, or C. And we're going to need this for some of the find commands, actually. and this is, hint, hint, some of the syntax you're going to be using in the assignments that you're going to have to do. List A through C. So same as above, but done as a range. So A through C, A, B, or C. And then we have all names not starting with A, B, or C. This caret symbol being the not symbol, not an asterisk, or exclamation point, but the not being the caret symbol. I'm not quite sure I think it's called a caret symbol, I'm not quite sure. Can't remember at this point. So not starting. So let's talk about the Unix copy command, where we have a copy that can be used to copy a file, leaving the original file untouched. So it's not like the move, but it's the copy. Same thing you have in Linux, or same thing you have in DOS. So CP stands for copy space old file, new location. This would be relative if you're at the same location as the old file was. You don't have to be. You can copy it from anywhere you want. So here's to make a copy of a file from both the original and the copy are going to be all in the same directory. We've got index.html to home.html. We can copy and change it at the same time, actually, but just by renaming the file. So if we copied index.html to home.html, end up in the same directory. If we copy it, we can copy it and move it by essentially creating another copy somewhere else. Not really a move. So to make a copy of the file that results in the copy remaining in its original location, but is housed in a different directory. So index is still going to be in the current location, but the dot dot is going to send us up to the parent and put it up there in terms of the subdirectory academic, and it's going to put it in there. We don't actually have to rename. We're not renaming it. We're not moving it, so we don't actually have to specify the name of the file. It's going to keep the name index.html. It's just going to copy it into a different directory. And if we make a copy of a file, that results in a copy having a new name and is housed in a different directory. That's when we change the name. So that's where we've taken index.html, and this is all on one line. You can actually put it on two separate lines if you want, until you actually no, that's not going to work. This is just scrolled. This is not going to work if you put it on two different, because once you hit that enter key, it's going to take the command. It's going to go, wait a minute, incomplete, missing the destination directory. So there's a way of doing it. You have to put dots on the end of it, but let's not worry about that right now. Actually, with a forward slash, so to concatenate the two sentences, but let's not worry about that right now. But what we're doing is taking this index file, we're copying it into this other directory and renaming the file at the same time. Here's the move command. Move command doesn't keep the original, it takes and removes the original. So mv has two purposes: to move the files from one directory to another, and also to rename the files. So we can rename them with a move. We don't have to keep them at the same name. So syntax is the move, the old file, new path name, new file name. So to move a file from one directory to another, we would say mv space index.html, and we're moving it to friends, and it's going to keep the same file name. It's still going to be called index.html. But we're moving it up to the parent because we're going dot dot, go up to the parent and put it in friends instead. To rename it, it would stay in the same directory, but it would be moved, which means we got rid of, instead of making a copy, this is actually more efficient because if you don't want the original anymore, it's just like a rename. You moved it from index.html to home.html, no more index anymore. So it's a rename actually. And to move the file and rename it at the same time, we're going to move it and rename it. So index.html goes up to friend and it changes into home.html. Kind of like the same thing we did with the copy command a few minutes ago. Deleting files. RM to remove. There's no DEL. So syntax RM, name of the file. So to delete a single file, this is where it becomes interesting. We can say RM space index.html. And then we have this answer yes to confirm delete. Not all systems are going to do that. But some systems by default, depending upon how you've got this parameter set in your shell, will say confirm delete. And then you can turn confirm delete on and off in terms of your settings for your parameters, or your shell script essentially, your startup script. So to delete multiple files with an asterisk, we use remove space, everything that has HTML in it as a wildcard. So the answer Y to confirm each one of the files instead of just one time. To remove the directory, to delete directories, the directory must be empty. Same problem you have in Windows actually. Or do you have that problem in Windows? Can you delete? You can delete a directory that's full of stuff. You can't do that in Unix. Instead you have to go -R to recursively delete everything inside of it. Which, one extra step. Syntax is the remove directory space of the directory name. To delete a directory images, remove directory images to confirm. I'm not going to show you the -R. I think it was left out on purpose because you need that for one of your assignments. So you'll have to look up the man pages for remove directory to figure out how to do it something recursively, or how to do something without the confirmations, or how to do something in different styles of doing it. The commands are quite powerful because of the switches. Here's some other useful commands you might find handy. Password, to change the password on the system. It allows users to update their own passwords. Exit, to end your Unix session. You can also use bye, type in BYE. So exit's more common. Clear gives you a blank screen. You can also use CLS as an acronym. Who, lists everybody's logged in. I didn't type in who. I said who am I? I type in who. Finger username. Retrieves information about the user. So Finger actually is a utility that's used to actually retrieve data to say, you know, who is this person? Where's their home directory? Who is this person? How long are they logged in right now? A bunch of information comes out about the user. Calendar, CAL will actually display a calendar for the given month. In fact, all these commands work on your Mac systems too, which is kind of interesting. Date displays the current date of the system, obviously. Bang bang repeats the last command. Those are the 2 exclamation points. So if you don't want to hit the arrow keys up and down, and or use the history, because you can actually traverse through the history of the commands that you have entered in if you want to. But if you don't want to do that, you can go bang bang, and you can repeat. Or repeat the last command beginning with a selected letter, bang, and then you put the letter in there, A through Z. So, and then we have this more, this character symbol, which is kind of hard to find. On my keyboard, is below my delete key, and more added to the command. We'll actually put in this thing, at the bottom of the page that says, press the return key or page up or page down to scroll. So it stops the scrolling and gives you it in pages instead of all of it at the same time. Because, it's really hard to read it when it flies across your screen and you can't, catch everything. And then all of a sudden, oh, it's got out of view, it's gone. So you would type in ls as an example here, -LT, and then this up and down pipe symbol essentially is the pipe symbol. More. I'm just going to put those stops in, so it stops at each page. And then to temporarily stop a process, you would go Control-Z to stop something. It's like Control-C, essentially, to terminate. It's Control-Z. FG brings a process from the foreground that has been stopped. So if you loaded something in the background, you can go FG to see foreground process is what it stands for. And it brings it in so that you can delete it, I don't know, do something about it, check the status of the in the foreground. So bringing something from the background to the foreground. Vacation, I turn on an auto reply for email. So actually that still works these days, even though you don't use Pine, which is an email program. Then, it's actually a text editor as well. So here we go, Pine. Launch an email client. Emacs, starting an Emacs editor. These are kind of like VI, start visual editor. 8 sections in terms of the online manual pages. There's actually a format to it. There's categories of games, file formats, system commands, system calls. That's why it's actually kind of the internet makes a lot of sense, because you can actually navigate through the online manual, the man pages, in a graphical kind of environment instead of doing it manually in the Unix environment. It's pretty much the same thing. So when you use the man pages, and one of your assignments will have you do this actually, you type the word man space and the command that you're interested in finding out about. So to look up on the CP command as an example, you go man space CP. To look up the ls, man space ls. Control-C exits the manual, terminates it actually. Terminates it completely. So there's everything you ever wanted to know about, well, not everything you ever wanted to know. It's just a preview on how to run commands. And part 1 of today's lecture. Part 2 is the 4A, which is only 20 slides. 20 slides going to show you the Unix startup and the shutdown, which is kind of interesting because we talked about kernels already. We talked about Unix commands. We talked about the concept of scripting and the concept of the shell and kernel booting up and giving us the shell. So this lecture is 20 slides of an extremely high-level overview about how the system actually starts up and shuts down. In terms of it, you're not going to learn everything you need to know about how to build a kernel and have it do all this stuff. But for those people who are interested in the terminology and interested in actually what's going on, it's kind of like Windows in a lot of ways, but different. Windows, you got, command.com, and you got autoexec files. You still have that actually, Windows 7. You still have command.com. And it's the way of the kernel booting up, and then you got the Windows system, the desktop that boots up, and all the services that start, and then your network icon comes on, and all the other stuff that happens. Linux is not so obvious, actually. It's more configured, it's more configurable, and the system administrator can actually select and easily add stuff to startup scripts and control what's called the bootstrap. And bootstrapping, and control the startup scripts, run levels, different run levels for different users, which means some things are going to load before other things do, some things are going to have a higher priority. User stuff's going to end up happening when the user logs into the shell instead of when, why load all the stuff for users until they actually log in? Why set everything? And then also the system shut down in terms of what happens in terms of the processes. Monolithic versus microkernels. Microkernel is based on the operating system itself. The monolithic is based on the operating system itself. It's both doing the same thing. However, we have a separation with what is involved and how much is packed into the kernel in terms of the concept. Here's the user mode. Here's the kernel mode. Down here on the bottom is this kernel mode. So we have the hardware, then we have the kernel mode. In a microkernel environment, we have a small kernel, kind of a small kernel, but we have everything directly linked to it. In a monolithic, we have one size fits all. Think of mono as one, where we've got, this is custom designed for the hardware. This has got only drivers, only things that are needed for the system. This one is loadable. We have device drivers that get loaded on, because we have one size fits all kernel. Kernel loads up. Bunch of modules have to load up on top of the kernel. This is what all these modules are about. These are the different, file systems, schedule, virtual memory manager, device drivers, dispatchers. This is a short list of these items, and these are called kernel loadable modules. So depending upon what kind of system you have, the boot's going to be different. This system's going to load everything. It's going to take a while. This system's going to load, and it's going to load, it's going to load. And finally we get to the user mode, and the user mode is up a little higher because we have the small kernel, we have everything loaded on top of it. And these are it's just nothing more than the order in which things are loaded and what does the kernel actually contain and what's being loaded in user mode. So out here is an example in this microkernel environment. We have a very small kernel, we have everything loaded afterwards. So out here in user mode we have application interface, device drivers, file system support. Everything is loaded on top of this kernel instead of being loaded by the kernel in a kind of a one-size-fits-all kind of environment. But we pick and choose what's going to be loaded. And then we have the applications on top. And the applications are pretty much on top of considered the user mode, and we have a system call interface. We still have a system call interface over here. But we have more drivers, more stuff loaded on. This is kind of what we have today. This is kind of where we started from initially. We've moved into this kind of a concept. This is how Windows runs, actually. If you ever noticed, we had the file manager, we have file system, we have we plug and pray. We stick stuff in there, and allows us to easily modify what drivers are being loaded, what services are being started and stopped and stuff, and it's all controlled in the user mode. This is an embedded piece of something. It's a bitsy small little thing in which we've got everything loaded, and then we have this user mode. User mode's going to put out a loop that's going to look for touchpad interfaces for a microwave oven or something. It's going to very small control, very little stuff is being loaded after this kernel is being loaded. And the user mode is just to get and run system calls. This is more designed for the desktop environments, where we've got the ability to load on file systems, device drivers, add new stuff, and be more dynamic in the user mode and change our operating environment as we're using the system. So depending upon what we're doing, this is easy to upgrade. You've got a microwave oven, you just burn another module on it. You burn another kernel. Kernel's got everything on it. Kernel's going to do everything. It just fewer files. You just put here. You got to have the ability to load a module, so we can actually load stuff. If we have this type of, we have to load stuff in both situations, but through system call interfaces, we have to just load a module, or see what modules are loaded and unload a module. But long story short, the configurations, we see varieties of this. Not every Linux system is going to follow one or the other in general. It's going to follow one or the other, but they're not always going to follow the same thing. So we're going to have differences in the boot sequence in terms of what's going to happen. So bootstrapping means starting the system, the process of loading the kernel into memory. We have boot modes. Boot modes are normal, single user, rescue. Kind of like the F10 option. Boot without networking support, boot in safe mode. But for Linux, the default is normally a multi-user mode, so we're going to load stuff for support for users. Or we can load it just in terms of, getting us to a system administration prompt. This is kind of a crude, yet it's not too bad, actually. way of describing the boot sequence. This works for any type of kernel environment, actually. What we've got is the BIOS. That's not too bad. And then we have grub. It's a menuing program. We don't necessarily have to have grub. We can have another menuing program, or we don't have to have a menuing program at all. You could just boot the kernel. But the first thing that actually does get initialized is the kernel. So the kernel boots up. It's kind of like going to the first sector, first couple of sectors of the hard drive and saying, here, start command.com. It's the same concept. Kernel is initialized. And then these are scripts, actually. Everything past this is a script. Kernel starts out and init is number 1, or actually init's 0. And then we start in terms of the process numbers. And then we start loading processes by running scripts. The scripts are going to initialize hard drives, set up configurations, set up the multi-user environment. And then we have run levels here where we have got different run levels that specifies the script by a kernel script, is a script by a user script, which user scripts are added to the boot process. We can add, we can delete. The stuff in right here is configurable. This is pretty standard because we need to have hard drives, we need to have network support, we need to have hardware initializations. This here is configured by the user sometimes. You know, they want the system to boot up and add something, a particular device that they have. And then one big branch of the scripts actually gives us the login shell. And then from here our desktop gets loaded, or something else, or we just use the shell essentially. And then we end up having, you know, an environment in which we can configure any login shell script as well if we wanted to. But that's actually what's called the boot process. And I can't go through each one of these things. It would be like 2 or 3 classes on this actually, and it would be different depending upon the Linux breed that you've got, which is different than like the Windows environment, like in the old days when we had an autoexec.bat and a config.sys file, and we had configurable scripts that we could do. That's very specific as to the breed and what it is you're running, and whether or not your modules, whether or not your kernel has everything in it, or whether you're loading stuff in the user mode. So, in terms of the process, what it is that we're doing is we're loading and initializing the kernel first. Then we're detecting and configuring devices. Kind of the same thing Windows does, actually. Then we're forking off the system processes. And then we have daemon processes that get forked off. One might be a print queue, as an example. One might be a backup. One might be a monitoring a safety or something, security level script. And then we stop if we're going to be in the user mode, single user mode. And then if not, then we're going to run scripts to set up user accounts and terminal interfaces. So then we run the startup scripts, and then we start the multi-user operations that might be going on. So we have this thing called a bootloader, and that's the grub system. And so the rest of this slide is going through, skipping the BIOS, but starting with grub and going through the entire process. It's about 20 slides. You can download it and read it in a lot more detail, but some of it is, I wouldn't say outdated. It's just, you know, grub for an example. You may not have to use grub. It's not all necessary. You might not use a bootloader at all. Bootloader allows you to actually, from the BIOS, the bootloader loads. And what ends up happening is then you get to select. Do I want to run Windows? Do I want to run Linux? Do I want to run... And what it's doing is it's attaching to different operating systems at different, you know, on different hard drives, in different locations, or different partitions. And it's giving you an option. In fact, you can even set the bootloader up for the same hard drive, same partition, but different kernels. It's just allowing you to select the kernel that you want to load. Grub is actually quite popular. You can boot multiple different types of operating systems. Lilo, which is the Linux bootloader, same thing. It's, single user, rescue, it has some default modes in it. So whether you use a bootloader or not depends on what you're doing with your hard drive. A lot of people who get Unix systems, Windows systems, and then they put the Red Hat disk in there, and they says, oh, Grub, you want to use Grub? Yeah, you want to use Grub. Otherwise, you're going to lose your Windows system. How are you going to boot to your Windows system? It's going to, you turn the computer off, you turn it back on, it's going to boot to Linux. So you use grub to flip back and forth between the different operating systems that you have installed. This is an example of a grub configuration. And again, I'm not going to go through it all, but what it's setting is default locations to where to find the kernel, where to find the hard drives, where to find the operating systems that you get loaded on. An example, here's one for Fedora, for Windows XP, for Red Hat, for different versions of Linux. So a lot of testing people, a lot of people load multiple dual boot systems. This is actually what's referred to as a dual boot because you can boot more than one, 2 or 3 different operating systems from the same menu. So, the system processes in a BSD system, we have swapper, init, page daemons. This would be like on a Windows, on a Mac system. On AT&T, kind of outdated example here. Or invisible to Red Hat would be a scheduler, init tab. These are different sets of processes that get loaded from different scripts that start to initialize hardware, essentially, in the environment. In terms of the startup scripts, this is how we set the host name. How do we know what our computer's called? Our time zone, our checking our hard drives, loading our hard drives, mounting our hard drives, removing files from the temporary directory, making log files, configuring system interfaces, network interface, starting daemons, network and services, and stuff like that. The RC asterisk scripts, we load text files that are scripts in here. It goes to the directory and we just load everything in the directory. The kernel knows from the startup process they have a master script, and the master script loads everything else. So if you want to change your boot process, you go in and you edit these text files and you take out all this stuff. Or you add your own, like you have this piece of hardware that needs to be initialized and you don't want to keep mounting it every time the system boots, so you add it to the script file, to the RC list, and you put it in the directory, and then voila, it runs automatically. It's kind of like adding something to the autoexec.bat file in a DOS environment. So, init tab initializes the system for use, sets the user modes, the actions for processes, uniquely identifies entries. These are just different switches in terms of the format of what's in this particular. And these are directories, by the way. And in the directories, you load the switches, the scripts. Init tab actions, you can start the process only once, start it multiple times, wait for something else to finish before you do it. Set the different run level. And the run level is going to give us your priority. You know, is it going to run first, second, third? Is it going to run for admin users, for all users? In terms of virtual consoles, these are your remote logins and your console capabilities, and you're loading on, you're spawning on. Depending upon how many consoles you create, this may or may not save memory. It just basically configures the environment for, different features that the system's going to support. Here's our run level example. And these are kind of different. I mean, in terms of their definitions, the numbers, everything's usually associated with a number. Because we have RC scripts that we can go, .5, .6 or something. And a run level determines when something happens in terms of the mode. So we have single user mode. It runs, multi-user mode with no networking. Full multi-user shutdown, reboots that run the script. When is the script going to run, essentially? And what's going to take priority over it? In terms of setting the run level, when you go through and you start looking at, in fact, if you have access to a Linux system, just go into the etc. init tab directory. You'll see they look like files. They're scripts, and they all have different run levels associated with them. And in terms of the run level scripts, the actual script itself is stored in this particular directory. And what you have is like a master list that says run these scripts. And it goes through each script and go to this directory, find the script, run this. And it basically opens up the file and runs the commands inside of the file. What are the commands doing? They're just initializing the system. They're setting the environment variables, doing stuff. And then we have messages that occurs. We could set up dmessage. Actually, you can go to your MacBook actually and go to a terminal prompt and type in dmessage, and it keeps a log. It's a history of all of the scripts and all the activities that happen. And if your system's booted up, it should show you the history of all the boot messages. Actually, are you doing it now? Does it work on your... I'm curious. I haven't run it in years. DMESG. Will it bring it up? No. What was it saying?
Not permitted.
Not permitted. Oh, you're not logged in as... When we get all done, I'm going to run it if I remember. Because I don't want to stop my place in the menu in the lecture. Oh, why not? Let me just try now. Let's just go to terminal here. Nope, I thought I hit terminal. Operation not permitted. Sudo. Let's go. I have to log in. Oh, here's another command for you. Sudo had to be If you want admin privileges but you're not logged in as the admin, you have to provide the admin password when I type this in. So you type in sudo dmessage. If I know the admin password, which I do, it will run the command. Haha! So type in run sudo, which makes you a sudo admin is what it does. It doesn't change your privileges to admin, but it allows you to run admin commands. And so if I do that, what I see here is a history of everything that happened when I booted the system up, which is kind of different. You don't get this in a Windows system. But what I'm looking at in terms of the scripts, I have no idea what I'm looking at. Our 64-bit mode enabled, Darwin kernel version loaded up. It'll go through loading up the drivers. It'll go through initializing the system. And the scripts obviously are located in different directories. The ones that failed to set up. I see some error messages and stuff. This way you can kind of troubleshoot problems and say, hey, my airport doesn't work. Well, I have a problem with my airport or something, or my USB doesn't work or something. I can go through the D messages and see, look, it said timeout, failed, or something, and then I know they have the wrong driver loaded, or I have the wrong something. But anyway, it's a great way of kind of diagnosing what happened in terms of the bootstrap process. Let's see if I can get back to that. Oops, there it goes. Ha, look at that. I'm getting good at this. Alright, so it's actually in bin, dmessage. Gives you a history of the boot right. It's convenient to search. In fact, you can do a find on the dmessage. You can string that command together, pipe the output into a file, or pipe the output, put it into something else, and use it to search through to see. Because normally that is actually kind of large. And it's like maybe several different pages. So interactive setup, we don't have that. I don't have that. We don't have interactive setup. Red Hat allows that actually, which is kind of like do you want to load this? Do you want to load that? Do you want to load this? Do you want to load? As the boot process continues through, you can say optionally, yes, load this. Yes, load that. It helps you when you're troubleshooting the system and everything comes in and all of a sudden it stops. But it was working to a certain point, so then you can interactively stop. See if you can get to a prompt or something. So after we have the system startup, we have the system shutdown. And the system shutdown is the turn off. Well, just turn off the computer. That's really bad. As I mentioned in the last class, we turn it off, we end up having open files, and the entire inodes and everything get corrupted, essentially. So we have commands that we type in. We have reboot, which is essentially going to wait for everybody to log off. We have, and then reboot the system. We actually have reboot now, reboot R, shutdown R. Halting the system, halt, shut down. The switches, use the man pages, look them up. But are we going to wait for everybody to log off before we shut down? Are we going to shut down now? Are we going to wait for background services to finish? Are we going to shut down background services first and then shut down the foreground services? Are we going to close user jobs that are opened? You know, when you shut down now, or you shut down, and now is not even on the screen here. There's a now that says shut down now. It means forget about it. Just shut everything down. And that's like, you know, it doesn't save anything, but it makes sure everything's closed safely. Changing the run level, you can do shutdown -I for different modes, which means, you know, shut it down and just shut down this user, or shut down the entire system, or shut down all telnets or something, or shut down external remote users or something. So when to shut down? Well, when you have failures, when you're maintaining, upgrading, regularly scheduled, house cleaning. User notifications. You can actually send out emails. You're going to have support pages and things like that that actually say shutdown status. You can set the status and shut the system down, essentially. So that, believe it or not, was everything you ever wanted to know about, probably not everything, but it was a brief overview, introduction to the shutdown and the boot up process. Unfortunately, we get different processes with different Unix breeds, but the general overview of what actually happens is pretty consistent. And that slide, it had this one here. That's the de facto standard in terms of what actually happens. And then what ends up happening is just you figure out, oh, I have this script it has to run. And then you go, well, where do I add it? And then you learn all the instructions for adding it for the kernel support comes here. For user mode support is in like the red area. And oh, is it shell level? Because every time we load up a shell, we can run a script. And we have login scripts that run for users who log in. And we don't have to worry about that in here. We worry about it down here. So what ends up happening is you figure out, well, what is it that I'm trying to boot in terms of the service, in terms of the utility, and where do I load the script? And then generally you figure that out as trial and error. And you go, oh no, it's loading too late, or it's loading too soon. Because you have more control, and I would say in the Unix environment you have more control over when something loads than you do in a Windows environment. So. Well, we're going to get on early today, because that's all I want to cover today. Because I don't want to get into something big, and then the next week we don't have class. So next time we're going to actually kind of get into like maybe some CGI stuff, some gateway stuff, and Unix services. And because your first project is on working with Perl. So you can have that. You can actually do assignments number 1, 2, and 3 if you'd like. You should have everything you need to know for that. And you can go through some of the lectures I didn't cover and kind of see some more commands and stuff as well. Any questions? Nope, then we're done for today.